Good afternoon, everyone, respected teacher and my dear friends. My topic for the presentation of seminar is Green Electronics, Sustainable Design and Manufacturing. And my seminar guide is Professor Nida M. Biju. There are my contents included in my presentation. Now let's move on to the introduction part. Green electronics is an emerging area of researchers focused on natural compounds and environmental friendly synthetic materials. A key objective is to enable the integration of electronic circuit with living tissues. This field builds on the promise of organic electronics for low cost and energy efficient materials. Green electronics can lead to unimaginable functionalities such as being integration into the environment. Now let's move on to the history part. In 1970 to 1980, early awareness. The environmental movement of 1970 drew attention to pollutions and resource depletions. In the 1980s, concern about the electronic industry's environmental impact began to surface, particularly regarding the use of hazardous materials in manufacturing processes. In 1990, toxic material restrictions. The introduction of regulation addressing hazardous substances in electronics, the European Union Restriction of Hazardous Substances Directive implemented in 2006 restricted the use of certain hazardous materials like lead, mercury and cadmium in electronic products. In 2000s, energy efficiency emphasis. With growing awareness of climate change, there was a shift towards improving the energy efficiency of green electronic devices. Programs like Energy Star gained prominence, encouraging manufacturers to develop energy efficient products and consumers to make environmentally conscious choices. Also in 2000s, e-waste concerns are also introduced. The proliferating of electronic waste became a significant issue. The improper disposal of electronic devices led to environmental contamination. Efforts were made to establish e-waste management system promoting recycling and responsible disposal. In 2010s, Design for Environment principle. The concept of design for environment gained momentum. This approach involved considering environment factors throughout the product life cycle, including material selection, manufacturing processes, and end-of-life disposal. In 2010s, renewable energy integrations. As the importance of renewable energy became more apparent, some electronic manufacturers began incorporating sustainable energy sources into their operations. This move aimed to reduce the overall carbon footprint of electronic devices. Also in 2010s, circular economy adoption. The concept of a circular economy gained traction in the electronics industry. This approaches emphasis product durability, repairability and recyclability, promoting the reuse of component and minimizing waste. And 2010 and at present, green certification. Various certifications such as EPEAT were introduced to help consumer identify environmentally friendly electronics. This certification considers factors like energy efficiency, recyclability, and use of sustainable materials. Ongoing innovations. The evolution of green electronics continues with the ongoing innovations in sustainable materials, energy efficiency, and waste reduction. Manufacturers were increasingly recognize the importance of incorporating eco-friendly practice into their business model. Now let's move on to what is green electronics. The electronics produced through environment-friendly processes are green electronics. They take into account the consumption of energy and production of carbon made out of recycled materials. Green electronics reduce the consumption of vital natural resources. Green electronics, also known as eco-friendly electronic or sustainable electronics, refers to electronic devices and technologies that are designed, manufactured and used with a focus on reducing the environmental impact. The primary goal of green electronics is to minimize the negative effect of electronic products on the environment throughout their life cycle, including production, use and disposal. Why green electronics are important? Green electronics are important because of make a positive environment impact globally using sustainable and eco-friendly manufacturing materials and approaches. For that, we need to focus on resource conservation and energy efficiency methods such as recycling and reusing electronics. Proper e-waste management also play a critical role in building a sustainable future. For that, we have to consider efficient e-waste reduction method and management strategies that do not affect human health and overall environment. Green electronics is also important because of the increasing global consumer demand for power efficient and eco-friendly products. New advancement and innovations in the tech industry enhance the need for green electronics. Overall, green electronics play a vital part in building a sustainable and energy efficient future. Now let's look at what are the latest trends and innovations in green electronics. Green electronics are constantly raising their demands and need for building a sustainable and eco-friendly future. Here are some latest trends and innovations in green electronics. Energy efficient electronics. The energy efficient electronics that contain proper power distribution and management system can reduce extra power dissipation and consumption, decrease greenhouse gases and lower electricity bill. Recyclable electronics. Recyclable electronics components, devices, gadgets, and systems can reduce e-waste and decrease the need for new product resources. Sustainable manufacturing. Using sustainable and eco-friendly techniques and materials during the manufacturing of electronics contribute a lot of saving the future. Green data center. Using energy efficient and sustainable technologies and IT infrastructure can reduce the power usage and impact the environment. Organic electronics. Organic and recyclable electronics components and systems can reduce power, resource and e-waste. All of these trends are all of these are the latest trends and innovation in green electronics that will revolutionize the future in few years. Now, challenges in implement green electronics. There are several challenges and issues the industry is facing currently in implementing green electronics. Let's discuss in briefly. The first biggest challenge in is design and development. There are some design limitation constraint and a complex supply chain affected the overall industry innovation. The development cost of this electronics is relatively high compared to the standard market rate. The second biggest issue is the lack of consumer awareness and behavior. The people are not fully aware of this critical issue and their global impact. For that, we should spread the education, training and awareness of a large audience as much as possible. Companies focusing on enhancing products life cycles to reduce this issue. On the other side, in some countries, there is a lack of recycling infrastructure due to that discarded electronic become e-waste. All of these challenges are important to consider and keep in mind when producing sustainable green electronics. These latest devices, LED lights are another simple example of green technology. Avoiding the fluorescent lights can substantially add to the efficiency of the light because they use up less energy. Solar power gadgets. Solar powered chargers and devices have become increasingly popular. This includes solar power banks, solar backpack, and even solar powered watches. Electric vehicles. Electric cars and bikes were gaining traction as a suitable alternative to traditional gasoline powered vehicles. Major automobile manufacturers were investing heavily in EV technology and the availability of charging infrastructure was expanding. Green data center. Data centers are adopting more efficient cooling technologies and renewable energy sources to reduce their carbon footprint. Biodegradable electronics. Researchers have been experimenting with biodegradable electronics components which can reduce the environmental impact of discarded electronics. Latest technology. Low power microcontrollers and microprocessors are widely used in IoT devices, allowing them to operate on battery power for extended period. Energy harvesting technologies capture and convert ambient energy sources such as solar kinetic or thermal energy into electricity. This can power small electronic devices and sensors without the need for traditional batteries. AI-driven energy management. Artificial intelligence and mechanical learning algorithms have been applied to optimize energy usage in data centers, industrial processes, and smart home, leading to significant energy saving. E-waste recycling innovations. New recycling methods and technologies have emerged to recover valuable materials from electronic waste more efficiently. These innovations help reduce the environmental impact of e-waste disposal. Research is ongoing to develop more efficient and eco-friendly battery technologies, such as solid-state battery and lithium-sulfur batteries with higher energy density and longer lifespans. Light emitter diode LED. Opto Optoelectronic devices have played a crucial role in illuminations, mobile devices, and smart home. The use of biodegradable materials in light-emitting devices such as LEDs and light-emitting electrochemical cells could enable the fabrication of renewable and eco-friendly display for healthcare electronic devices as well as other suitable applications. Recent progress in this field has mainly focused on how to apply biodegradable materials to light-emitting devices properly, thereby allowing for the replacement of expensive and unsustainable components without any obvious loss in performance. This section introduced the most used and widely studied biodegradable materials in LEDs, focusing on their performance, applications, and feasibility with the different type of devices. In the past 10 years, white ILEDs have significantly developed and obtained a place in the lighting market. They have been widely used for illumination, front automotive lights, signaling, backlights of liquid crystal display, etc. There are 5 components integrated in commercial WILEDs: electronic driver, heat dissipating system, emitting chip, packaging system, and components for light extraction and color conversion. Other electronic devices. In addition to solar cell OFETs and LEDs, there are other devices, examples battery sensors, drug delivery devices, etc., that would greatly benefit from the use of biodegradable materials. A power source is one of the most important components in regard to biodegradable electronic devices. However, a fully biodegradable power source has proven to be a major challenge in the application of such devices. Green processing for green electronics. Devices fabrication by mean of green processing is as important as the use of biodegradable materials in green electronics, and it includes the use of non-toxic solvent, eco-friendly functional layers, and large-scale low-cost fabrication method. Green processing can effectively suppress the emission of toxic substances into the environment during device fabrication. Simultaneously, high-performance devices created through green processing are also needed, especially when compared with conventional methods. Therefore, balancing green processing with the device's performance is the key for successful green fabrication. Future insight of green electronics. Green electronics will enhance with new innovations, eco-friendly and energy-efficient solution in the coming few years. People have started to understand the importance of green electronics and sustainable environment for the future. If we talk about the future of the green electronic industries, various things will integrate such as innovative and sustainable materials, energy harvesting, integration of renewable energy, e-waste solution and collaborative efforts. Also, the integration of emerging technologies such as artificial intelligence and the Internet of Things will enhance performance and connectivity and make intelligent green electronics. Features. Energy efficiency. The features of green electronics are energy efficiency, sustainable material and components, enhanced product life cycle, renewable energy integration, eco-friendly manufacturing and packaging, reduce e-waste, etc. Some goals: reduce energy consumption, reduce waste, improve products design and performance, reduce business expense, eco-friendly agriculture, reduce water consumption, reduce air pollution, and reduce carbon footprints. And now let's move on. Now let's look at the disadvantages and advantages of green electronics. The advantages: reduce environmental impact, energy efficiency, longer lifespan, recyclability, reduced toxic materials, positive brand images. Disadvantages: higher initial cost, compatibility issue, performance trade-off, limited innovation, e-waste recycling challenges. Applications: energy efficient devices. Green electronics prioritize energy efficient, reducing power consumption during use. For example, energy efficient LED lighting, low power processors in laptops and smartphones, and Energy Star rated appliances. Renewable energy systems. Sustainable electronics play a crucial role in renewable energy systems such as solar panel, wind turbine, and energy storage system. This technology rely on efficient and environmentally friendly electronic components for energy conversion, storage, and distribution. In healthcare, medical devices and equipments are incorporating green electronics to reduce power consumption, minimize hazardous materials, and improve longevity. In electric vehicles, green electronics are integral to the development of electric vehicle, efficient power management systems, regenerative braking system, and battery management electronics all contributes to reduce the environmental impact of transportation. Smart grids. Green electronics are used in the development of smart grids which optimize energy distribution and consumption. This system help reduce energy waste and greenhouse gas emission. Eco-friendly packaging. Sustainable electronic packaging uses recyclable or biodegradable materials, reducing waste and environment impact. Manufacturers also minimize the use of harmful chemicals in packaging materials. Now let's move on to the sustainable design. Sustainable electronic engineering is the discipline of designing, developing, and operating electronic products and systems that meet the needs of the present without compromising the ability of future generations to meet their own needs. Sustainable design is an approach to creating products and services that considers the environmental, social, and economic impact from the initial phase through to the end of life. The goal of sustainable design is to reduce negative impact on the environment and the health and well-being of building occupants. Sustainable design principle includes extending product lifespan, avoiding the depletion of natural resources, reducing waste by making products that are recyclable, compostable, or endlessly reusable. Raw material extraction. Raw materials extraction is the process of collecting or creating raw materials from the natural environment for the production of goods and services. Material processing. Material processing is the series of steps that transform raw material into finished goods. Part manufacturing. Part manufacturing is the process of following a plan of efficiently and consistently created products that meet their design goal. Assembly. Assembling is the act of putting things together or gathering them in one place. Synonyms of assembling includes assembling, gathering, collecting, and compiling. Product use. Product usage is data that describe how and when customer use a product. It can include materials, about how long customer use a product, how they use it, and when they use it. End of life. Sustainable product can recycled, reused, and repurposed or composted. Sustainable electronics are designed to address environmental challenges posed by electronic devices. They focus on extended life cycle and reducing e-waste. Sustainable electronics can be designed to be a durable, modular, standardized, and repairable. They can also be designed to use energy efficient while in use. Sustainable electronics can be designed to the sustainable in the following ways: optimized embodied energy and low carbon dioxide footprint in the production and distribution, no hazardous materials for the environment and people, conflict-free minerals, optimized use of energy while in use, designed to last. Now, Now let's move on to the manufacturing area. Green electronics manufacturing aim to reduce hazardous waste by using alternative non-hazardous materials that prevent the products from producing mass amount of e-waste. Green electronics make a difference and contribute to the reduction of toxic materials in the environment. Sustainable manufacturing is a relatively less known and significant element of sustainable development, including three function elements: sustainable products, processes, and systems. It is important to develop quantitative predictive model for sustainable product design and manufacture in order to understand the integral role of these elements sustainable in product manufacture. Energy efficiency. Green electronics aim to use energy efficiency to reduce power consumption during operation. This includes optimizing the design of components, circuits, and software to minimize energy usage. Material selection. Manufacturers choose materials that are environmentally friendly, non-toxic, and recyclable whenever possible. This reduces the environment footprint associated with the extraction and disposal of materials. Recycling and waste reduction. Designing products for easy disassembly and recycling promotes the reuse of valuable materials and minimize electronic waste. Responsible disposal methods are also emphasized. Longevity and durability. Green electronics are designed to have a longer lifespan, reducing the frequency of replacement and the overall consumption of resources. Reduce the hazardous substances. Manufacturers aim to eliminate or minimize the use of hazardous substances such as lead, mercury and cadmium in electronic components and soldering processes. Now let's move on to the challenges. Implementing green design and manufacturing practices often requires investments in research, development and new technologies. This upfront cost can be a barrier for some manufacturers, especially smaller ones with limited resources. While there is a growing awareness of environmental issues, consumers often prioritize factors like performance, features, and price over environmental consideration when choosing electronic products. This can make it challenging for manufacturers to market and sell green electronics. The disposal and recycling of electronic waste remain a significant challenge. Many electronic products are not designed with easy recycling in mind, and improper disposal can lead to environmental contamination. The transition to efficient manufacturing processes can disrupt established workflow. Initial costs are high, green products are expensive, natural resource depletion, electronic waste pollution, high energy consumption, social inequality, carbon accounting and disclosure, language barrier, equipment downtime, shortage of skilled workforces, poor quality control, unstable demand for products and increased competition. Conclusion. Green electronics prioritize the preservation of the environment by reducing energy consumption, minimizing hazardous materials, and promoting responsible disposal and recycling. Green electronics focus on energy efficient technologies and manufacturing processes, helping reduce greenhouse gases emission and energy costs during the product's use phase. Through strategies like easy disassembly and recycling friendly design, green electronics help combat the growing issue of electronic waste, minimizing the burden of landfill and ecosystem. Here are some way to make electronic device more sustainable. Choose green product, maintain and repair your device, sell or donate your old device, recycle your e-waste, use renewable energy sources. These are the references. Thank you.